Let's do another example. How about a three-dimensional example? So let's set up line integral of f of x comma y comma z equals x over y plus z over the circle of radius 3 centered at the point 0, 0, 8 parallel to the xy plane. So the region we're integrating over, this circle is being described in words, but let's go ahead and draw a picture so that hopefully we're on the same page about what the words are. I'll get some axes in here. So there's 0, 0, 8, let's say, right there's 8, and then there's this circle that comes around like this. Let's just say it'll go in a direction that's counterclockwise and when looking from where positive z is. So if you go up very, very high, a bird is flying in the sky and looking down at the xy plane, this circle looks oriented counterclockwise. So this curve C will be defined by x of t is equal to 3 cosine t. Let's write that better. 3 cosine of t. Y of t is equal to 3 sine of t. Z of t, well, is just the constant 8. Every point on that circle has z coordinate 8. And then t here, it's a full circle, so t goes from 0 to 2 pi. Okay, then if we were to set up an integral over c of f of x comma y comma z ds, this would be the integral t goes from 0 to 2 pi of, let's see, our function f is a fraction. In the numerator it said x, so we replace x with x of t, well, 3 cosine of t here. In the denominator there's 3 sine of t plus 8 for y plus z. We have ds gets replaced with the derivative of 3 cosine of t is negative 3 sine of t, and then we'll square that, plus the derivative of 3 sine of t is 3 cosine of t, and we need to square that, and the derivative of 8 is, well, 0, and we need to square that. Of course, that term is not really doing anything, but let's just put it in here to make it clear what's going on in a different problem. If we needed to. And let's just comment that this part right there actually equals 3. And if you needed to complete this problem, we're not going to do it, but if you needed to, this could be done using u is equal to 3 sine of t plus 8, right? Because the derivative of that morally is that. Well, not morally, it just is. Okay, so this would work out real nice. Let's also go ahead and at least set up the integral. That was really what the question was intending to ask, but let's just, as follow-up, yeah, we're done with the problem there, but let's just set up the integral, as long as we're here, good practice, of the function with respect to y, with respect to x, excuse me, with respect to y, and with respect to z. Why not? Couldn't hurt to just get a little more practice of these thingies because they, it's just something a little newer. So just like it looks very similar to what we had. So integral 0 to 2 pi, 3 cosine of t over 3 sine of t plus 8. We just don't have this thing. We only have the contents that was in the first term, other than the square. Yeah, so we'll have negative 3 sine of t dt. For the next one, this will be integral 0 to 2 pi 3 cosine of t over 3 sine of t plus 8, and then we would have here a times a 3 cosine of t dt. For the last one, this would be integral 0 to 2 pi 3 cosine of t over 3 sine of t plus 8, and now we actually just have 0, right? That's the derivative of 8 after all. So dz dt is 0 because the derivative of 8 is 0 dt. So look, this whole thingy is 0. This one, the rest of these would take these would take a little more work to do, but let's just comment because this one's easy enough that the value of this would be 0. Now, one bit of notation that I'd like to introduce. Notation. So if you see, yeah, let's just get the word there, notation. So a little bit of shorthand is in order. You're going to see this kind of thing quite a bit, so it's just worth mentioning. So let's just suppose, let's say that f of x comma y and g of x comma y are functions. Okay, then you're gonna see very often, like as a notation, you'll see kind of a shorthand integral over c of f of x comma y dx plus g of x comma y dy. So this is new notation. It ought to look a little strange to you because once there's a dx, you ought to be thinking that this is done and there should be another integral sign or something like this, right? But as a shorthand, almost every calculus book does this. This here is short for, so let's clarify what it really is. It's integral over c of f of x comma y dx, maybe we'll throw in parentheses just to make sure it's clear, plus integral over c g of x comma y dy. Maybe we'll throw that in parentheses just to make it clear. So it's like there should technically be another integral sign there, but people tend to be a little lazy about this, mainly because needing to integrate something that looks like this will actually happen very often in this chapter. So and then this like dx, well, that's like the one that we set up here, and then this integral that ends in the dy, it's like this one that we set up right there. I should also comment that in addition to whatever function you have, f of x comma y or g of x comma y, you'll also see an even more lazy and shorthand notation where it won't be the x comma y in parentheses. That's all left out. So you might just have f dx plus g dy, just like that. But it's understood from context that this would still be the function that's here. Like this, don't read this any differently. It's just laziness. And in fact, when this occurs, people often, though you could still use a lowercase f and a lowercase g, just usually end up using a capital P and a capital Q. Again, don't read into it as if it's anything really all that special. This is just shorthand for integral over c of p of x comma y dx. Let's just put in parentheses just to make sure it's clear. Plus integral over c of q of x comma y dy. One other thing I should just mention in this part is that the type of functions that you see like here, sorry, no, maybe not there. This is what's called a scalar field. So previously, if you saw f of x comma y is equal to x squared y, we've called this thing just a function of multiple variables, or I like to use the word input here. This is not what the book does, but function of multiple variables or function of multiple input variables. We've been calling it that so far. It does go by actually another name. It is also called a scalar field. This is new terminology. I want to just mention it because a relatively new thing that we've seen is stuff that looks like this. So capital F typically, an arrow above, and let's say you get here. Now, I'm gonna make something up on the spot, like x squared plus y, comma y over x squared plus y squared plus 1. Close angle bracket. Then this is, well, a newer creature for us, but this is called a vector field. So don't want to overdo it here, but I guess when you see that word field, think about like a function type of thingy where there's multiple inputs, and then the word in front, scalar or vector, lets you know what kind of creature you're going to get as output. Are you getting a scalar, like here with x squared times y, or are you getting a vector, like right there, clearly a vector due to the angle brackets?